So welcome back again. We are done with this definition of magnetic field. We are done with magnet. We are done with classification of magnetic material. We are done with method of making magnet or method of demagnetization. That is what we have just explained. But the revision is that there are three methods of making an object to become a magnet, and there are three methods of making an object to lose the word magnetism. Electrical method, single touch, double touch. These methods are used to magnetize an object. Then electrical method, mechanical method, heating method, these three methods are used to demagnetize a magnet. So let's start from factors that determine the magnetic field strength. So when I say magnetic field, what are the methods that will determine how strong their magnetic field is? This is a magnetic field, for instance, because this is a magnet we are treating. So what is the strength of this magnetic field? How big or how small is going to look? Some factors will determine it. The meaning is that the magnetic field is not equal always. There are some times where it is very strong. There are times where it is very weak. But there must be factor that will determine how weak or how strong the magnetic field is. So what are the factors that determine the strength of the magnetic field? One of them is called angle of inclination. Angle of declination. Angle of declination or variation. That's another name. If you don't remember declination. Another factor is angle of inclination, which is otherwise known as what? Dip. Angle of declination or dip. Then another one is horizontal factors. Then the last one is a vertical factors. So these four factors we have on the board will tell us how strong the magnetic field is going to be. Now let's pick the first one. The first one is called angle of declination or variation. Angle of declination or variation. By definition, angle of declination or variation is the angle formed between the geographical north and the magnetic north. The angle formed between the geographical north and the magnetic north. What do I mean? Let me draw the four cardinal points. This is geographical north according to the geography. Now, when you place a compass needle around here in order to settle in the north, the compass needle may settle like this, showing that this is north. So here is the geographical north. Here is the magnetic north. Now the angle between this geographical north and this magnetic north is called angle of declination or variation. I take it again. This north is representing geographical north. This line is representing magnetic north. You allow magnet to settle, and the magnet does not settle on the same line as the north on the north of the geography. The magnet a little bit deviates, bend, showing that its own north is somewhere. It's still very correct because this is the north for geography. But the magnet has settled to show that this is north. Meaning the magnet has created a particular angle between its own north and the north of the head or geography. And that's why we say angle between the geographical north and the magnetic north. So this is geographical north, and this is magnetic north. This is geographical north. So between the geographical north and the magnetic north, then I have an angle there, which is called angle of declination or variation. So number two, angle of inclination or dip? Let me redraw that. The first one, geographical north. Then let's have here to be our magnetic north. So angle between there is angle of variation or declination. Now, so let's go to the second one, angle of inclination or D. Angle of inclination or D. This is the angle. This is the angle. So I'm defining this now. This is the angle between, look at it very well. This is the angle between the earth resultant magnetic field. This is earth resultant because the continuation of this geographical knot is this line. So this line in magnet shall be called earth resultant of magnetic field. Earth resultant of magnetic field. That's the name of this line. So the definition of this line is that the angle between the earth resultant, this is resultant, the earth resultant of magnetic field and the horizontal. This is horizontal. So the angle between the earth resultant of the magnetic field and the what? Horizontal is known as angle of what? Inclination. I take it again. This is a resultant from this result. This line is as a result of this line. So we call this one resultant of this. So the angle between this resultant and this horizontal what? Line is called angle of inclination. But we cannot call it ordinary resultant. That's why resultant of the earth or resultant earth of the magnetic what? Field. And the what? So the angle here, let it be beta, and the angle here let it be what? Alpha. So alpha is angle of declination or variation because it is an angle formed between the geographical knot and the what? Magnetic knot. Now beta or beta is an angle of inclination or D because it is an angle formed between the resultant earth magnetic field and the what? Horizontal. So how big this one is, how big or how small this one, those two is, will determine how strong. So the more the two of them, the stronger the what? Electric field. And the lower the two of them, the smaller the what? Electric field. Or the weaker the electric field. So let's go to the third one. Horizontal factor. This line too is one of the factors that will determine the strength. So the force along the horizontal line will also determine. So what type of force do we have along this horizontal line? We also determine the strength of the what? Field. Then this one too. What type of force am I having along this vertical line? What type of force am I having along this vertical line? So the size of the force on the horizontal line, the amount of the force along the vertical line will also determine how strong or how weak that electric field is. So in summary, I have 4 factors that will determine the strength of this electric field. One of them is alpha, which is the angle between geographical knots and the magnetic knot. One of them is beta, which is the angle between the resultant earth magnetic field and the what? Horizontal. The third one is the size or the kind of force formed along the horizontal line. We also determine. The last one is the type of force formed along the vertical line. So I am done with this one now. So the next thing we can go to is magnetic property of iron and steel. That will be discussed in our next class.